Hi, my name is Daniel Zlotnick, and my research study is a comparison of common flooring materials in minimizing head injury severity. I'm a junior currently attending high technology high school. The inspiration for this research study came about from my volunteer work with children who have disabilities. I noticed that many of the children I help fell out of their chairs frequently and injured themselves. I decided to investigate ways to make these children's environments safer. After an extensive literature review, I learned that 2.8 million American children visit the emergency room for a fall related injury each year. These injuries range in severity from non significant injuries to traumatic brain injuries, which can sometimes even be fatal. Furthermore, 82% of all falls generally occur in high traffic areas such as schools and hospitals. And the leading injuries that actually result from falls are head injuries. Several studies have also found that there's a strong correlation between the surface onto which a fall occurs and the resulting injury from that fall. And this is why my study is so important because it's actually comparing these flooring materials that are most used in high traffic areas. Specifically, my study compares common flooring materials in their ability to minimize head injury severity from falls. The four flooring materials in this experiment are vinyl sheet, luxury vinyl tile, which is also called LVT, vinyl composite tile, which is also called VCT, and linoleum. Now, I had a hypothesis for this study, and it was that luxury vinyl tile, which is also called LVT, will be statistically significantly lower from the control group in the most number of injury criterion, which I'll explain later. In my study, I 3D printed anthropomorphic heads, which were dummy heads. These dummy heads were created with the sole purpose of mimicking an actual human child's head. They were dropped onto each flooring material 35 times, and the acceleration of the head during impact was recorded. In other words, the number of trials was set to 35 per flooring material. The process for actually creating these anthropomorphic heads is shown in Figure 1, which includes as adding a silicone material called Ecoflex 0030 to simulate the skin, PLA filament to simulate the skull's viscoelastic properties, and modeling clay inside the head to simulate the brain. An accelerometer was placed inside the anthropomorphic head and recorded the translational, which is the X, Y, and Z directions, and rotational acceleration. And it's also important to note that the trial order for this study was randomized. I constructed a dropping apparatus to control for fall height. This dropping apparatus, which is pictured in Figure 2 in my garage, released an anthropomorphic head representing a child's head onto each flooring material, which was placed on top of a force sensor that recorded the force for each collision. The trials were all done on the same day to control for temperature and other variables. The flooring materials were also placed above an underlayment to increase the applicability of the results. This sensor data, the acceleration in translational and rotational, and the force data was used to calculate 11 different injury criteria. These injury criteria are used to assess the risk of head injury based on an arbitrary impact. Furthermore, lower injury criteria are known to be correlated to a lower risk of head injury or less severe injuries. The 11 injury criteria are head injury criteria, the generalized acceleration model for brain injury threshold, Cliven's linear combination, brain injury criteria, kinematic brain injury criterion, rotational injury criterion, GAD severity index, max impact force, maximum translational acceleration, maximum angular acceleration, and the maximum angular velocity. These injury criteria are used in a variety of industries such as sports medicine, automobile airbag testing, and playground safety, and it's being used in this study as well. As you can see in Figure 3, I actually had to modify one of the injury criteria, head injury criteria, also called HIC, in order to be compatible with my data analysis. This modification includes several graph dimensionality transformations and reductions. Furthermore, it converts HIC to HICD, which allows for the calculation of HIC from a free motion head form. I also used Python, as you can see in Figure 4, to precisely calculate the injury criteria for each trial. I used the Simpson's composite rule to calculate the exact integrals or area under the curve to increase accuracy of the injury criteria. A snippet of this code can be seen in Figure 4, as I said, but this isn't the full code. As you can see in Figure 5, after getting all my calculated data of all 11 injury criteria per trial, I did an assortment of ANOVA tests, or analysis of variance, to find statistically significant differences between the flooring materials in each of the 11 injury criteria. Specifically, ANOVA tests if there's at least one statistically significant difference between the independent variables, which include the control group, which was 35 drops onto no flooring material at all. So as you can see in Figure 6, I then did 44 one-tailed t-tests to find which flooring materials were statistically significantly lower than the control group in each of the injury criteria. If a flooring material was statistically significantly lower from the control group in an injury criteria, it was granted 1 injury criteria point. The flooring material at the end of the study with the most injury criteria points will be considered the safest flooring material in the study. In other words, the flooring material with the most green, as you can see in the chart, would be considered the safest flooring material. So here are my final results. The final point values for each injury criteria for each flooring material can be seen in Figure 7, where LVT had the most at 8 points, which is the blue bar, while linoleum had the least with only 2 points. Again, the flooring material with the most injury criteria points would be called the safest flooring material in this current study. So therefore, it can be concluded that LVT is the safest flooring material, or luxury vinyl tile is the safest flooring material to minimize injuries from falls because it had the most injury criteria points. Furthermore, my study shows that 9 injury criteria of the 11 tested, so the ones that were significant in the ANOVA test, can be used in aggregate to test the effectiveness of flooring materials to minimize head injury severity from falls. Some limitations that may have affected and impacted the results of this study are that the recorded Fmax exceeded the limit of the center in several trials, leading to a data cutoff in several of the trials and incorrect results. This may be one of the reasons why Fmax was not significant in any of the t-tests and was not significant in the ANOVA test. So future research is needed to determine the relative accuracy of the injury criteria to find which are more significant than the others, or better than the others, so that the point system for the injury criteria point system can be improved. Future studies should also test different flooring materials and other underlayments at different thicknesses to increase the applicability of the study and just simply to increase the results. A real-life application of this research is that LVT can be considered in the design of high-traffic areas to minimize head injuries from falls, or head injury severity from falls. Flooring material companies can also use this methodology to test their own flooring materials and release that to the public. So, thank you for listening.